everyone. Good morning, afternoon, evening. Dear authors and invited guests, welcome to Technical Session 6C. Myself, Priyanshi Goyal, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the International Conference on Machine and Computing Technologies for Sustainable Development, MCT4SD 2025, Manila, Philippines. The conference is being held in a hybrid mode. The physical event was held day before yesterday in Manila, Philippines, and the virtual event is being held through Zoom today and yesterday, that is 12th and 13th of December 2025. I hope you all will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 8 presentations. Please note that each presenter will be given 12 minutes for the presentation and 3 minutes for question and answers. On 10 minutes, I'll raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we start the session, I would like to introduce you all to the chair for this session, Sir Dr. Bharat Singh Deora. Welcome, sir. Thank you for joining us. Dr. Bharat Singh Deora is a senior assistant professor in Department of Computer Science and IT at JRN Rajasthan Vidyapeeth University, Jaipur, India. With over 25 years of experience, he has contributed extensively to the field of computer science as a faculty member, researcher, software developer, and project guide. Dr. Deora is actively involved in several national and international professional bodies, including the Computer Society of India, CSI, the Indian Society for Technical Education, ISTE, and the Institute of Electrical and Electronics Engineers, IEEE, reflecting his strong commitment to academic and research excellence. Thank you so much for joining us, sir. I request you to share a few kind words of wisdom before we take this session ahead.
Good morning to one and all, and good afternoon also. I am very thankful to GR Foundation and Amit sir, Aman sir, for inviting me in this session chair. So in this session, we will gain and exchange knowledge, and I welcome all participants, and thank you.
Thank you so much, sir. Now, without further ado, let's begin this session. First up, I would like to request Sir Athar Rajoba to kindly present his paper titled A Lightweight Hybrid Term Frequency Inverse Document, Frequency Ensemble of Logistic Regression and Naive Bayes for Fake News Detection. Do we have you here with us, Athar?
Yes, I'm there.
All right.
So
You
can you
can
allow me
share.
to share?
Yes, you can share your
Yeah,
screen now.
sure. Is it visible?
Just a second. Yes, it's
Mhm.
visible. Can you put it in slideshow mode?
Yeah, sure.
Thank you. You may start.
Just a second. Yeah. Hi all, this is Atharva Rajoba here, and I'll be presenting my research topic, a lightweight hybrid term frequency and inverse document frequency ensemble for fake news detection. And this work is co-authored by Anand Gugre, and this is done under my mentor Dinesh Kumar Saini. And we are here representing Manipal University, Jaipur, India. So moving on to the next slide. Yeah. So let's come to the global challenge of fake news. So the misinformation spreads rapidly across digital platforms and social media apps across the world. undermining democratic institutions, distorting public health responses, and fracturing social cohesions. The proliferation of false narratives creates an urgent need for reliable automated detection system. So this presents a critical challenge that how can we develop a efficient and scalable solution to identify misleading information before it causes a widespread harm. So we found a research gap and which motivated us to do this research topic. So the research gap we have found is the deep learning models which have high accuracy but computationally expensive, which requires GPU resources and extensive training time. And the multimodal systems which has complex architecture processing text, images, and metadata with limited interpretability, and which motivated us to develop a classic hybrid model which is underexplored, lightweight alternatives offering speed, transparency, and resource efficiency. Our work addresses this gap by proposing a hybrid ensemble that combines classical machine learning techniques, term frequency, inverse document frequency feature extraction with logistic regression and naive Bayes classifiers to achieve exceptional performance while maintaining computational efficiency and model interpretability. So this is the pipeline of our model in which the raw news data is collected, which has multiple thousands of articles and which is then pre-processed, which includes tokenization, stop word removal, lemmatization or stemming, and lowercasing and handling the special characters. So after pre-processing the data, it is transferred to term frequency, inverse document frequency vectorizer, which is then pushed into modeling section, which includes logistic regression and naive Bayes. So coming on to the data set and pre-processing pipeline, we have collected the data set from Kaggle, which is named after fake and real news data set. It contains 44,000 English language news articles, which is evenly balanced between authentic journalism and fabricated content. This is a balanced distribution ensures unbiased model training and reliable evaluation metrics. The pre-processing steps are lower casing, which is standardized text to reduce vocabulary size, noise removal, which eliminates URLs, special characters, and numbers, stop word filtering, removing the common words lacking semantic value, tokenization, segment text into individual word units, lemmatization, reducing the words to their base dictionary forms. Coming on to the main important feature of this model, it's term frequency inverse document frequency feature engineering. This transforms raw text into numerical representations that capture semantic importance. Our implementation strategically combines unigrams and bigrams to capture both individual word significance and contextual phrase patterns. So unigram features are single word terms capturing the individual lexical signals and vocabulary patterns, characteristics of fake verse, fake versus authentic news. And bigram features are two-word phrases preserving the contextual relationships and stylistic markers that distinguish credible from fabricated content. Coming on to the architecture of this model, in which we have used logistic regression model and naive Bayes, where logistic regression is a simple linear model that uses a weighted TF-IDF features to estimate the probability that an article is fake or real. In naive Bayes model, a fast probabilistic model that applies Bayes theorem and assumes each word contributes independently. After combining these two models, we have developed a hybrid model which combines both the classifiers by averaging their predicted probabilities for each class. This fusion strategy leverages logistic regression's discriminative power and naive Bayes generating model, reducing the individual model weakness while amplifying collective predictive strength. Here we can see the performances of our model. In hybrid model, we have gained 99.19% accuracy, which is the best overall classification rate. In logistic regression, we have got 99.08% accuracy, and while in naive Bayes, we have got 94.63% accuracy. The hybrid ensemble achieved exceptional classification metrics across all evolution dimensions with 99.19 accuracy and an outstanding ROC AOC score of 0.996. The model demonstrates near perfect discrimination between fake and authentic news articles. Precision, recall, and F1 scores are all exceeded by 99%, indicating the balanced performance across both the classes. The detailed evaluation matrix is like we have got hybrid hybrid model which overclassifies all other models of logistic regression and naive Bayes in all the metrics like accuracy, precision, recall, and F1 score and ROC AOC curve. Model interpretability and efficiency. Transparency through weighted terms. Unlike black box deep learning models, our hybrid approach offers clear interpretability. The TF-IDF weights and logistic regression coefficients reveal which words and phrases most strongly signal fake versus authentic content. High weight terms provide actionable insights into linguistic patterns, characteristics of misinformation. We have got the computational advantages like CPU, in which no GPU is required, reducing the infrastructure costs, fast training time, which approximately takes 8 minutes on standard hardware, and it almost took 25 milliseconds per article for classification. Limitations and considerations. So the limitations we found are language constraint, in which we have only generalized to English language datasets. Then domain generalization. The training data has come from a specific news source and time periods. And the other limitations are adversarial robustness and multimodal signals. The future research directions for our research topic are multilingual extensions, in which we have to extend to non-English data sets, and cross-lingual transfer learning for global applicability, and integrating deep learning models like LSTMs and BERT to capture deeper semantic and contextual understanding. The Another future research direction is multimodal features, explainable AI methods like LIME and SHAP techniques, and the last one is adversarial testing.
This
So
is a
let's
gentle
conclude.
10 minutes reminder.
Yeah, so let's conclude this research topic by focusing on our key achievements. This lightweight hybrid TF-IDF ensemble demonstrates that classical machine learning techniques remain highly competitive for fake news detection, achieving 99.19 accuracy with exceptional speed and interpretability. We have got strategic advantage in which the model provides an efficient, transparent, alternative to computationally intensive deep learning approaches, offering a clear interpretability through weighted features and rapid interference capabilities. Thank you.
Thank you, Athar. Are there any questions?
Yes. Athar, did you test your model across multiple news domains to check its generation ability?
No, sir, we have just trained the model on a single
English.
news source, and it was in a single language, English, and we are planning to do multiple linguistic data sets, train it on multiple linguistic data sets.
Okay. One more question.
Yeah.
What adaptations would be required to deploy it in real world news platform?
So we can use multiple deep learning models like LSTM, BERT, Lime, SHAP, and to implement it in real world, we have to use like images, videos as their data sets.
Okay. Thank you.
Thank you.
Thank you, sir. Thank you, Mr. Athar. Can you please stop presenting? Thank you. Moving forward, I would like to request Ma'am Carla Ramos to kindly present her paper titled Academia Industry Collaboration Designing Technology for Program Curriculum Enhancement. Do we have you here with us, ma'am?
Yes, ma'am. Allow me to share my presentation.
Yes, ma'am. Please go ahead.
So, is my presentation visible?
Yes, it's visible. You may start.
Okay, so I am Dr. Carla Carmela P. Ramos from Pangasinan State University, Philippines. So I'll be presenting Academia Industry Collaboration, Designing Technology for Program Curriculum Enhancement, my research. Okay, so the landscape of education is rapidly evolving due to technological advancement and shifting industry demands. So traditional models often fall short due to misaligned goals, lack of technological infrastructure, and weak policy support. So in response, hybrid partnership models blending formal agreements with flexible tech-enabled collaboration have emerged as promising alternatives. So academia industry collaboration has become vital for keeping curricula relevant and graduates' employability. So modern collaborations now go beyond student placements, focusing co-creation, shared infrastructure, and ongoing knowledge exchange. These partnerships fall into three categories: the formal, informal, and hybrid. So technology plays a central role, enabling remote teamwork, real-world simulations, and innovation-driven learning through platforms like virtual reality, cloud tools, and simulation labs. So policy as a key enabler, effective partnerships require strong policy support across all levels. So with flexible context-sensitive frameworks. So however, several challenges persist, such as a lack of evaluation frameworks for hybrid models, missing tech infrastructure standards, weak global policy applicability, underexplored long-term outcomes, and poor scalability guidance. So this study aims to address these gaps by focusing on the strategic integration of existing technologies, not inventing new ones, but to strengthen academic industry collaborations. So the objectives of my research are one, formulate and validate flexible hybrid models integrating formal and informal collaboration strategies. Provide standardized yet adaptable technology framework to support scalable framework. Third, propose policy recommendations that accommodate diverse institutional and regulatory needs. And fourth, define quantifiable metrics for evaluating collaboration success. So this study aimed to develop a comprehensive technology enhanced framework for academia-industry collaboration that is adaptable across diverse higher education settings and regulatory contexts. So for the methodology, for the method for objective one, so I reviewed 95 peer-reviewed studies from 2025 to extract trends in academia-industry hybrid collaboration. Thematic analysis identified key typologies and structural elements of effective models. So case studies, I conduct also case studies across 12 diverse higher education institutions in the Philippines, explore the real-world implementation of hybrid partners, focusing on governance, collaboration formats, and outcomes, and also integrated a qualitative insight from interviews and focus groups with quantitative data from administrator surveys using a sequential explanatory approach, ensured that findings were empirically validated and contextually robust. So this approach allowed for both theoretical grounding and practical validation of the TECA, or the Technology Enhanced Collaboration Architecture hybrid collaboration model. So for the method, for objective 2, I evaluated tech platforms. So I assessed 5 key platforms: the VR or AR, mobile app, simulation labs, cloud analytics, and virtual collaboration tools based on implementation rate, effectiveness, and ROIs across 12 institutions. So I conducted surveys wherein I collected quantitative data from over 150 administrators and 200 faculty or students to gauge usage patterns, satisfaction, and readiness for technology integration. And I also conducted semi-structured interviews with 50 plus industry partners to understand technological feasibility, relevance, and alignment with workforce needs. So this mixed approach ensured that the resulting tech framework is evidence-based, scalable, and aligned with both academic and industry expectations. For number 3, I examined 12 institutions to evaluate the implementation and impact of key policy components. So patterns of success were identified based on implementation levels. So, and also for the expert consultations, conducted interviews with 25 policymakers and academia industry leaders to gather insights on practical policy challenges and adaptable regulatory solutions. And Metasynthesis was integrated for findings from institutional data and expert insights to derive scalable policy principles focused on flexibility, inclusivity, and institutional adaptability. So this method ensured that the policy recommendations were evidence-informed, context-sensitive, and scalable across diverse educational and regulatory environments. And for the method number 4, with the defined indicators, develop standardized metrics, industry alignment, graduate employability, technology integration, and sustainability index. So based on surveys and institutional data. So, and also, I use SEM, or the structural equation modeling, with AMOS software to test the relationships among variables and confirm the internal consistency of the evaluation framework, and the triangulation and joint displays for integration. So for the integrated qualitative insights from interviews and focus groups with quantitative survey data using joint displays, enhanced interpretation, and ensuring robust validation. So this methodology produced a set of empirically validated scalable metrics that institutions can use to assess and compare the success of their academia industry collaboration initiatives. So these are the results for the hybrid partnership model performance comparison. So the TECA, or the Technology Enhanced Collaboration Architecture hybrid model, significantly outperform both traditional formal and informal project-based collaboration models. So it scored highest across all key metrics. So with the industry alignment, 4.0 versus 2.3 informal and 2.8 in informal. So for the graduate employability, 87% for the tech hybrid model versus the 65% and 71% for technology integration, 4.2 versus 2.1 and 2.6. And for the sustainability index, so the hybrid model has 3.8 versus the 2.2 and 2.0. So these improvements were statistically significant, showing that The tech hybrid model is more effective and sustainable for academia industry collaboration. For table 2, technology infrastructure and component effectiveness. So different technologies were evaluated for their use in academia industry collaboration. So the VR AR learning environments had the highest effectiveness but were least used. Mobile learning apps were most widely used and had the highest ROI 4.01. Virtual collaboration platforms and simulation labs were also effective, especially for remote and hands-on learning. So, high impact technologies like VR or AR are underutilized, while more accessible tools like mobile apps offer the best return. So the findings help identify which platforms are both effective and scalable. So for the policy framework implementation success rates, so the study compared how different policy factors influence the success of academia industry collaboration. So institutional support and stakeholder engagement were the strongest drivers of success, with over 90% success rates in high implementation settings. Funding mechanisms and regulatory flexibility were also important but had slightly lower impact. So institutions with low implementation of these factors showed significantly weaker outcomes. So strong internal support and active engagement from all stakeholders are more critical than external funding or policy flexible for successful collaboration. For stakeholder satisfaction by collaboration model. So stakeholder satisfaction was significantly higher under the hybrid model compared to traditional collaboration models. So industry partners and administrators showed the biggest satisfaction gains. Students and faculty also reported notable improvements. So the TECA hybrid model greatly improved satisfaction across all key groups, showing it is more engaging, effective, and well received than traditional models. So this is the developed TECA framework, which stands for Technology Enhanced Collaboration Architecture. So it is a hybrid academia industry partnership model designed to enhance higher education curricula through strategic technology integration and collaborative design. With the key features of TECA from the four findings: the hybrid collaboration model, technology integration, policy adaptability, and stakeholder-centered design.
This is a gentle 10 minutes reminder.
Yes. Yes, ma'am. Sorry po. So what it works? So it improves graduate employability, industry alignment, and stakeholder satisfaction. Promotes sustainable, tech-driven, and inclusive partnership, adaptable across diverse geographies, institutions, types, and sectors. Okay, so for the conclusion, so the TECA provides scalable, tech-enabled, policy-aware collaboration model. Hybrid partnerships outperform traditional models across all indicators. Evidence-based framework supports global curriculum enhancement and future research needed on cost effectiveness and long-term impacts. Thank you.
Thank you,
Hello.
ma'am.
Yes,
Yes, sir.
Yes,
Please
sir.
take forward the
Yeah.
questions.
Yeah. One thing I asked you, from where you collect the data for your this model, analyze this model,
Sir, apologies.
from where you collect the data, how you collect the data,
Through a survey, sir, and interviews.
survey and interview. Okay. Next is, how did you measure the impact of this collaboration on student learning outcome and employability beyond feedback?
Apologies, sir. Can you repeat the question?
I repeat the question. How did you measure the impact of this collaboration on student learning outcome or employability?
It's for the learning outcome for the employability. So actually, so based on the research and for the literature, the interviews and surveys. So this is where the results came from, sir.
Okay. Thank you.
And yes, sir. So and I also integrated a quantitative wherein I use the Amos SPSS software.
Thank you, ma'am.
Thank you.
Thank you. Thank you, sir. Moving forward, I would like to invite Sir Deepak Kumar to kindly present his paper titled An Efficient Semantic Graph-Based Clustering Model with Contrastive Learning. Do we have you here with us, sir? Is anyone else from the team present? Okay, since there is no response, we'll be moving forward. I request Ma'am Cecilia Gumone to kindly present her paper titled Analyzing Project-Based Learning in Bohol Island State University, Student Feedback Using LDA and VADER. Do we have you here with us now?
Yes, ma'am, I'm here.
Okay, just a second. Yes, you can share your screen.
Okay, for a while. Am I now visible?
Yes, ma'am, you are visible and your screen is also visible. You may start.
Good day, everyone. I am Cecilia Tigumanoy, and with my co-author, RJ Joy T. Ocampo. I am presenting our study titled Analyzing Project-Based Learning in Bohol Island State University Student Feedback Using LDA and VADER. Our focus is straightforward. We want to understand how students experience project-based learning using data-driven analysis of large-scale open-ended feedback. Project-based learning, or PBL, emphasizes authentic and extended project. It is widely valued because it strengthens collaboration and higher-order thinking, and many universities adapt it to better align learning outcomes with workplace demands. However, as PBL scales across institutions, it becomes harder to understand student experiences using traditional evaluation alone. That is why we turn to feedback analytics to capture patterns across many narratives, not just individual anecdotes. At Bohol Island State University, PBL is implemented across colleges, but evaluation is often still quantitative, focused on grades and scores. The missing piece is the qualitative layer, the students' reflections, difficulties, and perceptions that are usually written in open-ended form. Our study addresses that gap by analyzing open-ended feedback at scale. The specific gap we identified is that NLP has not yet been systematically applied to BISO PBL feedback. So we set 3 objectives. First, extract topics using LDA. Second, analyze sentiment using VADER. And third, use the findings to propose an action plan for PBL improvement. Our data set consists of 1,163 open-ended student responses from 5 colleges collected through purposive sampling. The largest groups came from COAS and CTEC, followed by CBM, CTE, and CFES, giving us a broad cross-college picture of PBL experiences at BISO. This slide summarizes the respondents' distribution by college, reinforcing that the corpus reflects multiple disciplines rather than a single program's experience. This is important because PBL implementation can vary by discipline, and we want our findings to be institution level, not narrowly departmental. Our approach is mixed methods through NLP. We use Orange data mining with the text mining add-on, and the pipeline is pre-process the text, run LDA for topics, run VADER for sentiment, then synthesize results into recommendation. This workflow let us capture both what students talk about most and the emotional tone they attach to those experiences. Before modeling, we cleaned and standardized the feedback, lowercasing, tokenization, stop word removal, and lexicon filtering, removing numbers and symbols, emphasizing nouns and verbs, through POS tagging and limiting the analysis to unigrams for clarity and interpretability. The goal is to reduce noise and ensure the topics represent meaningful content rather than formatting artifacts. This slide summarizes topic prevalence. The most prevalent themes relate to learning skills development and collaboration, teamwork, while real-world management themes and innovation, creativity appear less frequently. A practical interpretation is that students often frame PBL around two core experiences, what they learned and how they work with others. Meanwhile, creativity and real-world management are present but less consistently highlighted in reflections. At the same time, the word cloud gives an intuitive snapshot of what dominates the feedback. Terms like project, time, skills, experience, team, and group stand out strongly, indicating the recurring dimension students associate with PBL. This matters because it validates that our topic model is grounded in authentic and repeated student concern, not isolated statement. After pre-processing, LDA produced 10 topics, each represented by a set of high probability keywords. In our study, these topics were then interpreted and labeled based on the keywords and representative excerpts so that the output becomes meaningful for educators and administrators, not just technical results. To make the results more actionable, we mapped the 10 topics into higher order themes. This slide shows the topic to theme interpretations, which help translate LDA outputs into educational language and institutional insights. These steps is essential because administrators need clear categories to guide interventions. Next, we consolidate the topics into 4 clusters: learning and skill development, collaboration and teamwork, project management and real-world experience, innovation and creativity. For sentiment Vader, classifies responses into positive, neutral, and negative. Overall, neutral sentiment is most frequent, followed by positive, with negative as a small proportion. The heat map visualizes mean sentiment by topic and college, allowing us to see where sentiment is relatively higher or lower across clusters and disciplines. The key message is that students describe PBL in a reflective, moderately positive way. At the same time, negative sentiment is not random. It tends to appear around time pressure, coordination issues, and technical constraint, and it highlights that teamwork can be both a strength and a challenge. So PBL is valued, but it also creates predictable friction points that institution can address. Our recommendations operate on 4 levels: curriculum, clearer outcomes, rubrics, alignment, and faculty training on scaffolding, monitoring groups, and handling free riding or conflicts. Students, time management, role allocation, collaborations, and scaffold. Institution, resources, infrastructure, continuous monitoring. The main idea is to protect what students already value about PBL while reducing the recurring pressures that drive negative experiences. To conclude this study, demonstrate that combining LDA topic, modeling, and Vader sentiment analysis can transform open-ended student reflection into structured, evidence-informed insight for improving project-based learning at BISU. Thank you for listening.
Hello.
Hello, sir.
Yes, yes. How adaptable is this framework for other universities or discipline?
Pardon, please.
how adaptable is this framework for other universities or discipline? Your model may be applied to other university or discipline also. Okay, next.
If the university is using
Yes, yes.
PBL, sir. If the university is using PBL, sir. In the other university.
PBL.
Yes, project-based learning.
Yes. One more question. What were the most surprising sentiment patterns revealed by weather, and how did they influence recommendations for improving PBL?
Based on the results.
May I repeat the question?
Okay, sir. Can you
What
repeat?
were? Yes, yes, you speak.
Based on the results, sir, neutral is the most the students' response.
Okay, thank you. We will continue the next presentation.
Thank you, sir.
Thank you, ma'am. Moving forward, I would like to request Sir William Saitano to kindly present his paper titled Anchoring Quality in Education, Development of Strategic Quality Assurance Framework for Pangasinan State University. Do we have you here with us, sir? Is anyone else from the team present? Since no one is responding, we will be moving forward. I request Ma'am Saloni Jain to kindly present her paper titled Automated Psoriasis Lesion Segmentation and Severity Scoring Using Explainable Deep Learning, a survey. Do we have you here with us, ma'am? Is anyone else from the team present? Since there is no response, we'll be moving forward. I request Sir Arogya Swami to kindly present his paper titled Leveraging AI-Driven Upskilling and Reskilling Strategies for Employee Retention and Internal Mobility, an empirical analysis across key industries. Do we have you here with us, sir? Is anyone else from the team present? All right, we'll be moving forward. I request Ma'am Juliet Manner to kindly present her paper titled Personalized Learning Through Adaptive Intelligence, a multivariate exploration of its effects on student achievement and engagement. Do we have you here with us, ma'am?
Yes, ma'am. I'm here, ma'am.
All right, you can share the screen.
Can I share my screen first?
Yeah.
For a while, ma'am.
Sure. Your screen is visible. You may start.
For a while, ma'am. Yeah.
Your screen is visible.
Yeah, ma'am.
You may start.
Wait for a moment, ma'am. My screen is hanging. Okay, good afternoon to each and everyone. So I'm Juliet V. Minor and my co-author, Mr. Chrismar C. Aquino. Today, I am presenting my research entitled Personalized Learning through the, wait for personalized learning through the adaptivity of intelligence and motivated exploration and its effect on students' engagement. This research was conducted in the context of higher education, particularly in the information technology at Pangasinan State University. So, in the introduction, wait for In the introductions, the education sector is shifting due to the technology advancement. Okay, we're pursuing educators will think on how the learning divide. The traditional education models struggle to meet the diverse learning needs. There is a pressing needs of personalized learning and personalized solutions. The challenges of traditional model, these are the model fail to address the cognitive emotions and motivation diversity. As a result, okay, these are this engagement, inequality outcomes, and underperformance. The needs of flexible learner center of educations. These are the challenges in traditional. Adapted intelligence in educations. So the adapted AR offer personalized learning in the real time, tailors the content of facing the feedback based on the individual performance that provides also the dynamic, okay, responsive and learning experience on it. The research objective. The research objectives seek to address this gap by employing multivariate statistical techniques to evaluate the impact of adaptive intelligence on student performance and engagement on the higher education. Specifically, it's aimed the following. Number one, evaluate the effect of adaptive AI on the student achievement and engagement. Number two is investigate on how the cognitive readiness, engagement, and learning style predicted to success. Number three is the challenges and necessary conditions for implementing adaptive learning. And the theoretical foundation. So these are the references adapted for this research. The most of the learning is effective when that aligns with the learner cognitive readiness, according to Begets and Vygotsky. In the self-determinations, these theories as competence as a relatively as the key as the instincts of motivations based on the self-determination used by Deci and Ra. In the research designs, so we use the quasi-experimental designs, and we have the group traditional learning
Hello?
versus adaptive. Yes.
Your slides are not changing.
Okay. For a while.
Only your title slide is visible, ma'am.
Yeah. Wait, ma'am.
Is now it's visible?
Is it visible, ma'am?
Yeah, the research design slide is visible. But when you present the first slide is only visible. Can you move it forward?
Yeah. So, is that visible, ma'am? Moving forward?
Yeah, the challenge of traditional models.
Yeah.
Yes. Adaptive
Okay.
intelligence in education. Is that the slide?
Yeah. Okay.
Okay,
Thank you
you
very
can
much,
start.
ma'am. Thank you, sir. The adapted intelligence or adapted AI addresses the limitation traditional methods by offering the real-time, data-driven personalized learning. It's tailor the learning experience to each student and adjusted content facing and the feedback dynamically based on the performance, ensuring that each student get into the support they needs. In the Oh, wait, is this already done? I think this one. Okay, sorry for the slide. It's not functioning. In our research, we use a quasi-experimental design to compare the two group in the traditional learning group and the adaptive learning group. Both are enrolled in the Web Science and Technology courses as a part of Bachelor of Science Information Technology program at Pangasinan State University. In traditional group revise the standard lectures based on the instructions, while the experimental interact with the adaptive development learning platform. This system is an AI-powered adaptive learning platform designed specifically for development of students. It is also personalized the learning experience by dynamically adjustment of the content facing on the feedback of the student progress performance. Next is we do the multiple regressions showing next is the table 1. It involves this 90 participants, all and undergrad students enrolled in BSIT at the Pangasinan State University. This participant is carefully and selected random assigned on two distinct groups to ensure the group was comfortable term and demographic factor based on the academic performance. In the first group, we have the traditional learning group, consists of 45 students who receive the standard lecture based on the instructions and the traditional employee in the classroom. This group is followed the curriculum designs in our university, where the instruction deliver the course content throughout the lecture students and were expected to engage the materialized passive learning methods. In the second group, the adapted learning group is also included the 45 students with a total all in all is 90 participants. However, the traditional lecture dose is interactive with AI powered adapted development learning platform. This platform designed to personalize the learning experience by adjusting the content on pacing and feedback based on the student individual progress and performance. Moreover, we analyze the data using a multiple regression analysis to identify the pre-indicators of performance and factor analysis to exploring underlying factors related to engagement and motivations. Descriptive statistics help to summarize the pre-test and post-test result. The result of the pre-test, of the post and assessments revealed that the student adaptive learning demonstrated the significant improvement in the performance. The mean difference with positive 3.35, where the traditional learning group shows the modest increase of mean difference of positive 0.14. It's aligned, these were aligned for MOSTA, based on the reference found out the adaptive system is consistent of the performance across the multiple discipline, observe the significant improvement in the student outcomes and adaptive learning technologies were employed particularly in the problem solving. Our regression analysis is indicates the beta coefficients value with the 0.45 p-values or lesser than 0.05. It is a cognitive readiness of beta coefficients is equal to 32 and the p-value of lesser than 0.5, where the strongly predictive or predictors of this post-test performance align with the concept of scolding the learner try to the tailor on this current level of knowledge. In the contrast of this, the learning style, visual, audio, or was a significant predictor of performance, which aligned to this. The system adapted trends, traditional boundaries of the learning style, personalized learning pathway on the dynamic responsive to individual needs. To explore the dynamic influence of these students, these are the adaptive learning setting feedback data. The factor analysis revealed that the three key constructs engage of anonymous, competitive, and explain most of the variant in the data. These findings align the self-determination theory with the forced learning and control the learning and feel competent in this test. The outcome of this research provide the important insight regarding the real-world application of adapted learning system in the higher education. Teacher training significantly influence on how we adapt technological or technologies are incorporated in the instruction practice. In conclusions, adapted intelligence greatly improves student learning outcomes by offering personalized learning experience tailored to individual cognitive readiness and level of engagement. Number two, encourage or engagement of cognitive readiness were identified as strong predictors of student performance, emphasizing its important and active participations and prior to the knowledge in adapted learning. And then number three, we have the underscore the effectiveness of adapted learning technology in boosting student motivation, especially for satisfying psychological needs and automating of competence of described by determination theory. And last, successful implementations of the adaptive learning system required address challenges related to the teacher training, data privacy, and equitable access to technology across device student populations. Thank you very much for listening, ma'am.
Thank you, ma'am. Are there any questions?
Yes. How did
Yes.
adaptive intelligence impact student engagement over time?
As of the moment, sir, this is the continuations of our previous research. Since the traditional based on during our previous research, we use a system, or we develop a system for us to encourage or to help our students in this AI empowered, and then that is the outcomes of the platform and help them to increase their performance engagement.
And one last question.
Yeah, sir.
Which dimension of adaptive intelligence, for example, content adaptation, pacing, had the strongest influence on student achievement in your analysis?
Yes, sir. So we find this a second researcher's continuation for the previous, and then there is an impact on our student outcomes based on the performance level in their academic performance.
Okay, thank you.
Thank you very much, sir.
Thank you so much, sir. Thank you, ma'am. With this, we have come to the end of the session. I sincerely thank all the authors for their excellent presentations and contribution in this session, and all the participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this version of the conference. We'll be happy to have you in the next version in 2026 as well. All the presenters would be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of MCT4SD 2025. I would also like to thank our session chair, Dr. Bharat Singh Deora, for chairing this session. Thank you so much, sir, for joining us. Here's a small token of appreciation from the team of Global Knowledge Research Foundation and partners. I would just like to request you to add any last comments before we end the session.
Yes. Thank you thank you to all presenters for sharing their diverse and impactful research today. We explored advances in fake news detection, industry academia collaboration, project-based learning analysis, adaptive learning system, etc. Each presentation provided valuable insights, and these valuable thoughts keep us engaged, everyone. I appreciate the discipline of the presenters during the participation. With that, I formally conclude this session. I wish all the authors the very best for your next conferences and future journey. Once again, I am thankful to GR Foundation, Amit sir, Aman sir, and Priyanshi madam. Thank you.
Thank you so much, sir, for your kind words, and thank you everyone for your valuable presence. I would now like to request everyone to turn on their cameras so that I can take a quick snapshot before we conclude the session. All right, I will be taking it. 1, 2, 3. Thank you so much, everyone. Have a wonderful day ahead.
Thank you very much, ma'am and sir. Bye.
Thank you.
Thank you,
Bye.
Thank you,
ma'am.
everyone. Thank you.